Dear students, I explained here cascade programming method. This is the final method, the last method in fifth unit. If we complete this programming, cascade programming method, so fifth unit was completed. So this method is also called as pole zero form or Gullmann's form. So these are the two different names for this cascade programming. In external examination, so any name can be asked. Cascade programming or pole zero form or Gullmann's form. So in this case, so the numerator and denominator are factorized like this. So the transfer function is s plus a by s plus b. Suppose the transfer function is like this, s plus a by s plus b. First we can simulate the denominator, that is, so how can we write this function s plus a into 1 by s plus b. First we can draw the 1 by s plus b simulation or program. After that, we can write the s plus a, that is numerator. So 1 by s plus b, how can you draw the program? Already we know 1 summation, 1 integration, and feedback block. The feedback block value is b, and this one is negative feedback. So this is the arrangement for 1 by s plus b programming. And the numerator s plus a. Already we know how can you draw the numerator programming. So s plus a. Here a not multiplied with any s, and s here s 1 multiplied with s. Already we know there is no s concept in state model. Only 1 by s concept will be there. That means integration concept is there. There is no differentiation concept. So already we discussed in previous videos. If s is there in numerator, we can connect that block one integrator before. If s square is there in numerator, we can connect that block two integrators before, like that. So that here s plus a not multiplied with any s, so that a is directly connected to output, and s multiplied with 1, so that one block is connected one integrator before, like that. So simulation of the numerator s plus a as shown below. So this arrangement for 1 by s plus b, and numerator is connected here. So a is directly connected to output summation, and s, so here s is connected one integrator before. So s multiplied with 1, so that directly connected the line. So this line value is 1. If any block is not there, the value of that line is 1, already we know. So this is the arrangement for s plus a by s plus b. Like that, we can arrange number of blocks in parallel, sorry, in series. That is nothing but cascade. So consider the example. Output transfer function T of s is equal to s plus 2 into s plus 4 divided by s into s plus 1 into s plus 3. Arrange this transfer function as below groups: s plus 2 by s plus 1, one group; s plus 4 by s plus 3, one group; 1 by s plus 2, one group. So we can group this not like in this format only. So we can draw, or we can group s plus 2 divided by s plus 3 and s plus 4 divided by s plus 1 and into 1 by s. Like that, we can also group the three different these different values. So group 1, group 2, group 3. Now we can draw the programming for group 1, group 2, group 3, and cascade all these groups. We can get finally the cascade programming answer. So now first group s plus 2 by s plus 1. First I will draw the s plus 2 by s plus 1 diagram or programming. So 1 by s plus 1. So this is the diagram for 1 by s plus 1, and the numerator is s plus 2. So 2 not multiplied with any s, so that 2 is directly connected, and s multiplied with 1, so that s is connected integrator, one integrator before. And second one, second function. So second function is s 1 by s plus 3. So that this is the arrangement for 1 by s plus 3, and numerator is s plus 4. So 4 is directly connected, and s multiplied with 1, so that s is connected before integrator. 1 is connected before the integrator. And last one is 1 by s. So 1 by s is nothing but integrator, so that simply we can connect the integrator. So this is the first group answer, second group answer, and third group answer. Finally, with these three blocks are three group answers are cascading, that are connected in series. So this is the arrangement for cascade programming method. Now we can draw the equations, or we can correct the equation from this diagram. First one is, so x1 dot of t. So x1 dot of t is nothing but, so output of this summation. So this summation having the two inputs. One input is directly from here. Here the value is x2 dot of t. So that one input is x2 dot of t. And the second input is 4 multiplied with x2 of t. So that x1 dot of t is equal to x2 dot of t plus 4 into x2 of t. And x2 dot of t is equal to x2 dot of t is nothing but this summation output. This summation having the two inputs. One input is minus 3 into x2 of t. So that minus 3 into x2 of t. And second input is this one. This output is this summation output. This summation having again two inputs. So that one input value is, so 2 multiplied with x3 of t, and second is directly connected here, that is nothing but x3 dot of t. So that they finally x2 dot of t is equal to minus 3 into x2 of t, so plus x3 dot of t plus 2 into x3 of t, that is x2 dot of t. And x3 dot of t is equal to this summation output. So this summation having the two inputs again. One input is u of t, second input is minus 1 multiplied with x3 of t. So that x3 dot of t is equal to u of t minus x3 of t. So these are the three equations. So now we can draw the A, B, C and D matrix. But here the problem is x1 dot of t is equal to x2 dot of t. So up to now we are getting the many equations, but all equations are having the format is x1 dot of t is equal to x1 of t, x2 of t, like that. So again here we can get one differentiation. So x1 dot of t is nothing but differentiation. Here also x2 dot of t also nothing but differentiation. Up to now we are getting the equations are x1 dot of t is equal to x2 of t plus x1 of t plus x3 of t, like that. We cannot get up x2 dot of t. So that, so these equations are not in standard form. So now we can change these equations into standard form. So so that here x2 dot of t having this one is standard format, this one is standard format, but x3 dot of t is not in standard form. So that substitute this x3 dot of t in second equation, x2 dot of t, we can get the standard equation. So substitute x3 dot of t in x2 dot of t. So we get x2 dot of t is equal to minus 3 into x2 of t plus 2 into x3 of t plus u of t minus x3 of t, that is equal to u of t minus 3 into x2 of t plus x3 of t. Now this equation is in standard form. And x1 dot of t also not in standard form. So substitute x2 dot of t in x1 of t. So next one, substituting x2 dot of t in x1 of t equation. Therefore x1 of t is equal to u of t minus 3 into x2 of t plus x3 of t plus 4 into x2 of t, that is equal to u of t plus x2 of t plus x3 of t. Now x1 of t also in standard format. So, therefore this one is standard format x1 dot of t, and this x2 dot of t is also standard format, this one, and x3 dot of t is also standard format. And finally output equation from the diagram, y of t is equal to x1 of t. So that we can draw the A, B, C and D matrix. So from these three equations we can write the A matrix, so and B matrix also. And output equation y of t is equal to x1 of t. Therefore here there is no u of t, so that d value is 0, and the matrix C is row matrix. So y of t is equal to 1 0 0. That means 1 multiplied with x1 of t, 0 multiplied with x2 of t, 0 multiplied with x3 of t. That is nothing but y of t is equal to x1 of t. So these are the A, B, C matrix. So this is the state model from different methods. So up to now we discussed fifth unit. So this method is the last method in the fifth unit. So fifth unit was completed.